The sun is high in the sky over Rocket Lab Launch Complex 1 on New Zealand's Mahia Peninsula. An Electron is standing tall on Pad B as we prepare to go to space for the 61st time in just under 20 minutes. My name is Muriel Baker and I'm a Senior Communications Manager here at Rocket Lab.
And I'm Matt Tier. I work on the avionics systems for Neutron. We're thrilled to have you join us once again to watch Electron take to the skies.
Today's launch is for our friends at iQPS, the Institute for Kyushu Pioneers of Space in Japan. They've named the mission The Lightning God Reigns, and if that name sounds familiar, it's because it follows on from our first launch for iQPS back in December 2023. Now that mission was called The Moon God Awakens, and it deployed a radar imaging satellite named Tsukuyomi-1. Today, it's the Lightning God's turn as we launch the first of 8 new missions for the Japanese Earth Imaging Company.
Across these 8 launches, Electron will expand iQPS's constellation of SAR satellites. These aim to provide persistent monitoring of Earth at fixed points every 10 minutes. Inside Electron's fairing is a single spacecraft, the QPS SUSANOO-I satellite, and it's headed to a 575-kilometre orbit.
Right now, we are just over 14 minutes away from sending that QPS SAR-9 satellite on its way to orbit. So for now, let's take a look at some of the numbers behind the launch vehicle that will take it there. So today's launch is our second for iQPS out of a total of 9 Electron missions that they have booked with us. It's also our third launch of the year so far, but our 61st Electron mission overall. And that includes our suborbital Electron variant HASTE. It will be our 57th liftoff from Launch Complex 1 since we've carried out 4 missions to date from Launch Complex 2 in Wallops, Virginia.
Each Electron has 10 Rutherford engines total. That's including 9 on the first stage and 1 on the second stage. So you'd probably think that means that we've sent 600 Rutherford engines to space or 610 after today's flight, but that's where you'd be wrong. We've recovered and reflown one of those engines before, bringing the total number sent to space so far at 609. Since our first launch in 2017, we hit 50 launches faster than any other commercially developed rocket in history. We also deployed well over 200 satellites to orbit. This year, we have more than 20 missions booked on the manifest, so we're quickly adding to that deployment tally. No doubt you memorized all those figures and ready for the quiz at the end of today's broadcast.
But for now, let's give the numbers a rest and listen in for some very simple words instead. Go or no go? And that is the question our launch operators in mission and range control will be asked shortly by Launch Director Paula Teres-Serralonga. They'll each report status on the various vehicle, ground and range systems they are responsible for, confirming whether or not they are clear to proceed with today's liftoff. So let's listen in for those calls now.
12 stations LD in Mission Core proceeding with go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Vicon.
Vicon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LDSAP.
LDSAP is go.
Go, no-go sequence complete. We are T-minus 11 minutes, 21 seconds and counting. We are go for terminal count auto sequence at T-minus 10 minutes. From this time, the 3-word procedure is in effect.
Anti-geysering is disabled. Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch off.
Stage 1 propulsion nominal.
Okay, the lightning god's reign has begun and we are on our way to space. Electron has lifted off from Launch Complex 1, cleared the pad, and is now travelling at over 800 kilometres per hour as it propels iQPS's satellite towards orbit. Now, one of the next calls you'll hear from our operators is max Q, and that's the point in flight when Electron experiences the highest aerodynamic loads. Let's listen in for that call.
Cleared max Q.
That's max Q behind us, and Electron is continuing its way to space for our 61st mission. Electron is now at an altitude above 17 kilometers, traveling at speeds past 2,400 kilometers per hour. Up next, in quick succession, we have MECO. That's main engine cutoff, which is when the first stage engines shut down. A few seconds later, Electron's first and second stages separate. At this point, Stage 1's role in the mission is now complete. But it's just getting started for Stage 2.
Shortly after separation, the single Rutherford engine on Stage 2 will ignite, and that will propel us the rest of the way to an elliptical transfer orbit. So watch closely to see all of this take place in the next few seconds.
Stage 1 propulsion holding nominal. Standby for MECO in 30 seconds.
"15 seconds to staging." Enter burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
And as planned, that sequence of milestones is now complete, and Electron's second stage is continuing to orbit. Now it's the fairing's turn. The two halves of the clamshell fairing will separate and fall back to Earth, exposing the iQPS satellite to space for the very first time. Those fairings, like the rest of Electron's structure, are made from carbon composite, so they're incredibly lightweight but also strong. It's why we're making Neutron's fairings from the same material. But unlike today's fairings, neutrons will stay attached to the vehicle for landing and rapid reuse.
Fairing jettison confirmed.
And there we have it. Electron's fairing has been jettisoned, and the QPS SUSANOO-I now has its unobstructed view of its new home in space. We are now coming up to 4 minutes into the flight with less than just a couple more minutes remaining in this second stage burn.
Guidance is nominal.
When it comes to launching rockets and spacecraft, we don't just build, then fly. We rely on rigorous test campaigns to ensure mission success. For new parts, we start with development testing, followed by design qualification, or qual. Qual testing stresses the design far beyond expected conditions it would endure for a nominal mission, with vibration, shock, thermal cycling, and thermal vacuum, or TVAC, being a handful of test examples conducted. Next up is acceptance testing, intended for real flight article hardware. These tests are typically less harsh on components versus qual as to not fatigue them. After all, these are being used on actual mission. The aim is to catch workmanship issues and performance variances. For Neutron, some electron components are reused but require additional testing due to the high acoustic and vibration levels from the more powerful Archimedes engines. The scope of Neutron's test campaigns cover individual components in isolation up to large integrated tests to ensure various systems, avionics, software, mechanical fluids, propulsion, all work together as expected. That includes tank pressure tests, engine hot fires, and as shown earlier, the hungry hippo.
All right, back to the mission you see on your screen. And next, we are getting ready to hear some of our 4 favourite words: battery hot swap successful. And that will mean that we have reached the point in flight when the depleted batteries that power Rutherford's electric fuel pumps are ejected from the second stage. We then immediately swap over to a fresh set of batteries to get us to the rest of the way to orbit. And that's why we call it a hot swap, since it happens while the engine burn is still underway. So as well as hearing the call out from operators, you should also be able to see the shiny silver batteries fall away from Electron on your screen. So eyes and ears at the ready for that flight milestone.
AGB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down. Battery jettison confirmed.
Confirmed delta successful.
Stage.
Okay, in the eternal words of InSync, we have said bye, bye, bye to those batteries. A fresh set has taken over with just a few minutes now remaining in the flight. And the average orbital Electron mission takes around 9 minutes to reach orbit, which means across more than 60 missions, we have spent more than 9 hours capturing views like this one on our multiple journeys to space. And still, I tell you what, it's a view we never get sick of.
With just over 7 minutes completed in today's launch, we have passed through most of the key milestones with just 2 more remaining. That's SECO, or second engine cutoff, and stage separation. This is where Electron's kick stage separates from stage 2 in preparation for payload deployment. But before that, we've still got a few minutes to watch that Electron's nozzle glow brightly before shutdown.
Okay, T plus 7 minutes, 47 seconds and counting, and everything is proceeding nominally so far. The operators in mission control continue to monitor vehicle systems closely as we approach that all-important throttle down and the second engine cutoff ahead of kick stage separation. Now, if you're keeping an eye on our speed, you want to see that dial at around 27 to 28,000 kilometers an hour, which will indicate that we have hit orbital insertion speed.
AGB discharge holding nominal.
Electron's 61st flight is coming to an end in just a few moments. We're now expecting to hear the call out, burnout detect mode, from mission control. Once we hear that call, you'll know that second stage shutdown is close.
20 seconds remaining.
SECO confirmed.
Nominal transfer orbit achieved. Stage separation confirmed.
And just like that, Electron's second stage engine has shut down as planned, and the kick stage is now separated to continue the rest of its journey ahead to payload deployment. Now, the kick stage will enjoy a gentle coast around Earth before it reaches its apogee, which is the highest point in its orbit. At that time, the 3D printed Curie engine on the kick stage will ignite and then raise the orbit to a circular one at 575 kilometers above Earth's surface.
Once in that circular orbit, it will be time to wave goodbye to iQPS's satellite as it joins its siblings in orbit. We'll come back for that Curie burn and deployment, but for now, let's take a trip down memory lane and look back at our very first launch for iQPS back in 2023.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
So on that mission, the moon god awakened, but today it is the lightning god's turn. And remember, today is launch number 2 of a total of 9 booked by iQPS on Electron. So many more views like that one are coming up in the next few months and years.
For now, though, let's take a break while the kick stage moves into position for deployment. We'll be back with you in just a jiffy.
Curie cutoff confirmed.
Nominal final orbit achieved.
Curie shutdown is confirmed. All that remains now is deployment of iQPS's satellite, and that's Electron's mission complete.
All right, we heard it internally on the nets. Payload deployment is confirmed, and welcome to space, QPS SAR-9. So as we like to call it, that is mission success with that payload now on orbit. Thank you to our mission partners iQPS for launching on Electron once again, and with 7 more missions booked together, we look forward to being on the pad for you again soon.
Well, that's our 61st launch done and dusted. The next launch is never far away, so keep your eyes on our social media channels and websites for details about our next launch, a dedicated mission for return constellation customer Kinéis. Don't forget, if you want to join the team that's making big things happen in the expanse of space, visit rocketlabusa.com and check out the careers page.
And thank you so much for joining us to watch another Electron launch. We love to share what we do with you, and we are so grateful that you are here cheering us on. So until next time, this is Rocket Lab Mission Control signing off.